Welcome to the second video of chemical reactions. So in this lesson we'll be explaining the stages in a chemical reaction, and the outcome for this lesson is to actually understand the energy changes that occurs in a chemical reaction. Okay, so now a quick revision for the previous lesson. We were talking about the conditions that must be met for a reaction to occur, right? So we said if we have particles of A and particles of B inside a container, the first condition that must be met is that the kinetic energy of these particles that will take part in the reaction, they must be at least equals to or greater than your activation energy, whereby your activation energy is the minimum amount of energy required for a reaction to occur, right? And condition number 2 is that they must collide with the correct orientation. So the reactants must collide with the correct orientation. So now for this lesson, we want to understand the stages, right? Given that now the reaction can occur. So if it can occur, it means that the activation energy, the kinetic energy is greater than or equal to activation energy. So condition 1 is met, and also they are colliding with the correct orientation, right? So if these two are met, then we can say reaction can occur. All right. So now, if the reaction can occur, let us look at the energy changes, or let us look at the different stages in a chemical reaction with the energy changes, right? So now let me draw the container again. And we had particles inside here. So particles of A or molecules of A. Okay. And up here we had two particles that are participating in the reaction for A. Okay. Which is this particle here that had 11 joules, right? That we said it's participating because 11 joules is greater than or equals to, it is actually greater than 10. And then particle of A, which has 15, which is greater than 10. Okay, and then for B also we have two particles. This particle here, which had 10, which was the required, which has 25, which is greater than the required. So we had two particles and two particles. Okay. So now the reaction can occur. Yes, it can occur. How many particles of A? 2. And then how many particles of B? 2. Okay. And for this reaction to occur, they must actually collide with the correct orientation. All right. So now we have particle of B here, which is a molecule. And we also have particles of A, which is a molecule. So now for this reaction to occur, this atom of A, it must combine with this atom of B to get a product. Let's say our product is C. Okay. So let's say our product is C. So it means C will have an atom of A and combined with an atom of B. So this is our product that we are trying to make. Okay. But now before we can get this product, these atoms in this molecule, they must be separated. It means that this must be separated and that must be separated so that this can be on its own, that can be on its own, that can be on its own, and that can be on its own. If this is on its own, then it can combine with this particle, which is also alone, right? So now we are explaining that these particles must actually separate, and these particles must actually separate. So these atoms must be separated. But now, what separates these two molecules, right? And what separates the two is actually energy. You apply energy to separate these two. Okay. So the energy will break the bonds in between those molecules. So it means that as these particles are moving, okay, as these particles are moving, energy is being absorbed, right? Because now remember, they do have energy. These particles, they do have kinetic energy, and they do have energy of movement, which is kinetic energy, right? And they are constantly moving randomly, so in a straight line, right? So in the initial stages of the reaction, these particles are still combined, okay? So it means extra energy must be absorbed here. And when energy is absorbed, that energy is going to be used to break the bonds between those molecules, the bonds between those molecules or those atoms there, okay? So that is the initial stage. So stage 1, energy is absorbed. But what is the function, or why is that energy absorbed? And that energy is absorbed to actually separate these two atoms. So it means that energy is absorbed to break down the bonds between molecules. Okay, so now that is stage number 1. So let us demonstrate that in this diagram or in this container. Energy is being absorbed, and that energy is going to break down the bonds between these atoms. So we have broken down the bonds between those atoms, okay? And then here we have broken down the bonds between those molecules. Same applies here. And that is the energy that is being absorbed. It's going there to break down the bonds between those particles. So now we have achieved stage 1. Okay, so initially these particles, they did have energy, okay, or the reactants, they did have energy, but now some of the energy needed to be absorbed so that we can break down the bonds between these two molecules, right? So now we have achieved stage number 1. So now at this stage, these atoms, they are very, very unstable, okay? At this stage, they are very, very unstable, meaning that this particle, it wants to react, that particle wants to react, that particle wants to react, or like all of these particles, they want to react because they are very, very unstable. And at this stage, whereby these particles are very unstable, we call it the activated complex. So these particles are activated to take part in a chemical reaction, right? So it means that after achieving stage 1, whereby the energy is absorbed to break down the bonds between the molecules, after achieving this stage, it is very important that the particles are now very unstable. They want to react so that they can be stable, right? So at this stage, we call it the activated complex. So at the activated complex, we can say that the particles of A, they are separated, and also the particles of B, they are separated, right? So if they are separated, this particle of A can combine with this particle of B. This particle of A can combine with this particle of B, so that you can get your product C, right? Which is that product over there. So it means that they have to be separated first. And after they are separated, that stage whereby they are separated is the activated complex. So that is stage 1, right? And then stage 2 is actually where these atoms combine. Okay, so it means that that atom will combine with that atom. Atom of A will combine with atom of B, right? So it means that reactants now combine. Okay, so when they combine, they are forming new bonds, right? And remember, in stage 1 you are breaking the bonds that were initially there. So here you are breaking the bonds that were initially there between these particles, but now you are forming new bonds. And now these new bonds, they are between particles of A and particle of B, which is what we want, which is our reaction, right? So reactants now combine to form new bonds. Okay. And what's very important, when you form new bonds, the sum of the energy or more than what was absorbed may be released. So what's important is that energy is released when new bonds are formed. But energy is absorbed when old bonds are being broken, right? So when you break down the bonds, energy is absorbed. So this is very, very important. Energy is absorbed. But now when you form new bonds, energy is released. So now let us illustrate these two stages in a form of a diagram, right? So that it can be simple to understand. So this illustration in a diagram, it will actually give us two types of reactions. Okay, so we illustrate these stages using a potential energy versus reaction path graph. So this is the reaction path, and that is the potential energy. All right, so initially when this reaction is about to occur, so before the reaction, actually your reactants, they do have some form of energy, right? So let's say initially they had this energy, or maybe they had an average of 10, for example, potential energy, right? So that is the energy, or that is the heat energy that the reactants had. So that is the heat energy of the reactants, right? So in the initial stage, we said energy is absorbed, right? So this is the energy of A and B initially, which is the reactants, right? Which is the energy of A and B initially. But energy is absorbed to break down the bonds, right? So it means if energy is absorbed, then it means energy will increase here. So energy is absorbed up until the bonds are broken down. Okay, so up until the bonds are broken down. So at that stage whereby the bonds are broken down, we have separated particles of A and particles of B now. So we have particles of A and we also have particles of B. And remember, this stage up there whereby these particles are separated, we call it the activated complex. That is the activated complex. Okay, so maybe in a question paper they might say, they might label that part to be A, and then they ask you what is A. A is the activated complex, right? And then maybe they ask you this part B. What is B? B is the heat of the reactants. Okay, so now this energy that you absorb, actually this energy that you absorb, that is the energy required actually for your reaction to occur, which is the minimum amount of energy required for a reaction to occur. And that minimum amount of energy required is what we call your activation energy. Okay, so that is the energy at the activated complex, right? And that is the energy of the reactants. So it means the difference between the two, it will give you your activation energy. So if you want to calculate your activation energy in this graph, it's from the activated complex to your heat of reactants. Okay, so now we said these are the reactants. Okay, so this was A and there was B, and then energy is absorbed here to do what? To break down the bonds, right? Energy is absorbed to break down the bonds up until they are broken down, and at that stage these particles are very unstable, right? So it means after this stage A will combine with B, A will combine with B to get your product. And now when new bonds are formed, okay, energy is released. Now the energy goes down like that. And then let's say new bonds are formed now. So now this energy up there, we now have products whereby we have that product C, okay, and that product C is made up of A and B. So that is product C. So now that is the heat of products. That is the heat of products. That value over there. So now this side you have products now, but this side you have your reactants. So energy was absorbed, and then that is the activated complex, and then energy was released to form new bonds. Okay. So in this case, we can see that the energy that was absorbed is from here up until the maximum up there, right? And energy that was released was from the maximum up until here. We can see that more energy was absorbed than released, right? So that gives us the first type of reaction. So if that is the case, if more energy is absorbed, than released, then we call that an endothermic reaction. We call that an endothermic reaction. All right, so in this reaction, we can see that if we can calculate the difference between the energy of the products and the energy of the reactants. For example, let's say the energy of the reactants is 10 and the energy of the product, which is greater than, let's say it's 25, okay, joules. If we were to calculate the difference, which is what we call enthalpy change, or the delta H, which is equals to the heat of the products minus the heat of the reactants, you can see that you would get a positive answer. That would be 25, which is heat of the products, minus 10, which is heat of the reactants, and your answer there would be 15, right? So you can see that you're getting a positive answer. For endothermic, your delta H, or the difference between the heat of the products and the heat of the reactants, is positive. So that is an endothermic reaction, okay? Delta H is greater than 0. So now let us look at another type of a reaction, okay? So you have your energy graph versus reaction path, right? So that is your potential energy. So let's say now initially you had that energy whereby these are reactants, okay? So let's say you had 30, for example, and then energy is absorbed, right? So energy is absorbed to do what? To break down the bonds between the reactants, okay? And then up there, that is your activated complex. So that is your activated complex, whereby the stage is very unstable. And then now new bonds, when new bonds are formed, energy is released. So now we release energy. And then at the end of the day, we have our product, which is C. Okay. And remember that the energy that we absorb, this energy from there up until the activated complex, okay, that energy is our activation energy. All right, so we can see that we have absorbed very little energy. Okay, we have absorbed very little energy. We absorbed, let's say, if there is 50, we absorbed 20, right? We absorbed 20. From 30 to 50, we only absorbed 20. And then we released from 50 to 10. So we released 40 joules of energy. So we only absorbed 20, but we released 40. So it means that we have released more energy than what we have absorbed, which is the opposite of what we had here. More energy is absorbed. So now we'd say more energy is released than absorbed. So it's actually the opposite. So now if you have this kind of a situation, then the type of reaction is now exothermic. So if you were to calculate the difference between the heat of the product is this value, right? And the heat of the reactants, which is this value of 30. So if you were to calculate the difference, which is the heat of the products minus the heat of the reactants, heat of the product is 10 and heat of the reactants is 30, then you can see that you're getting minus 20. You are getting a negative number. So if it's an exothermic, your delta H is less than 0. But if it's a positive number, your delta H is greater than 0, which means it's a endothermic reaction. So those are the two types of reaction. We explain this using the two stages of a chemical reaction. Stage number 1, energy is absorbed to break down the old bonds between the molecules, right? And this is the first stage here. And then the second stage, energy is released to form new bonds. Okay, so now we can see that we have achieved our outcome for this lesson. We understand the energy changes. Energy is absorbed just before the reaction can occur, and energy is released when new bonds are formed. And by understanding these energy changes, we can see that we can have two types of reactions, which is endothermic and exothermic, depending on the energy changes that occur in that chemical reaction.